We can use Appendix A in order to help us determine if any of these bases are going to deprotonate acetonitrile. The way I like to set up this reaction, or to figure out this answer, is to set up a reaction. So I have acetonitrile here. That's going to act as our acid because it's going to be deprotonated, and draw in just one base. So let's start with A. Our first base we are given is sodium hydride. Let's delete our question marks, and we're going to put sodium hydride here. Now keep in mind sodium hydride is ionic, right? Sodium plus, hydride minus. Na plus and H minus. It's really just H minus. That can come in, take a hydrogen off of carbon, leave a lone pair. That's where we get our anion. And our conjugate acid is therefore H2 gas. So let's fill in some pKa's. Well, we know hydrogen gas, if we find in our table, has a pKa of 35. So our conjugate acid has a pKa of 35. We need to also find the pKa of acetonitrile. And acetonitrile is going to be right here. It has a pKa of 25. Now, to determine which side of the reaction equilibrium is going to lie, there's a few ways to look at this. First, let's look at it mathematically. So the equilibrium constant is equal to 10 to the pKa of the product minus the pKa of the reactant. So in this case, 10 to the 35 minus 25 is equal to 10 to the 10th. What this tells us is 10 to the 10 times, there's 10 to the 10 times more sodium carbonate. If you the salt, 2 plus, so there's 2 sodiums, right? And CO3 2 minus. CO3 minus the base. What's our conjugate acid? Well, if one of the oxygens attacks or bicarbonate. And if we look for that in our table, we find HCO3 minus has a pKa of 10.2. Now, acetonitrile didn't change. It still has a pKa of 25. Now, which is a stronger acid? Well, this hydrogen-carbon bond is now weaker because it has a pKa that's lower than of the arrow. So this is just another way to check yourself if you're more acquainted with equilibrium constants. You want to just think about it. So for the pKa, the stronger the acid. Therefore, this hydrogen-oxygen bond, carbon-hydrogen bond. This is a stronger bond. We move on to the next one. What does that look like? Sodium plus and OH minus. Our base. Lone pair could attract hydrogen. Water. What's the pK of water? It's 15.7. So, is hydroxide strong? Hydrogen, that gives us ammonia. What's the pK of ammonia? It should be around 38. So, which acetonitrile or acetonitrile is more less that the bond strength in this carbon is weaker than the nitrogen. Equilibrium you put in this case enough base to do trial. So here's another base that's stronger than hydroxide. Sodium amide is stronger than sodium hydroxide. And the last one we have is sodium bicarbonate. So we looked at sodium carbonate. Let's look at sodium bicarbonate. So we have now HCO3 minus. And that can take a hydrogen to get us to carbonic acid. What's its pKa? I think we have to go up a page here and we'll find that carbonic acid has a pKa of 6.4. So, which is more acidic? Well, this has a lower pKa. Therefore, this hydrogen-oxygen bond is weaker